Hi guys, and welcome back once again. We are continuing with type 4 in this video where we use our identities. So far, you know that the identity that you can use is the quotient identity. Sine theta over cos theta is tan theta. Now, when it comes to the square identities, guys, things really get tricky. And I'd like to start this off by showing you actually how you factorize when you've got trig ratios. So let us have some review of factorization here, okay? Just to warm up your brains. So suppose I have 2x squared is equal to x. So how would you factorize this? You're not, how would you factorize this? You're gonna say 2x squared minus x equals to 0. That's the first step, right? I believe you saw that. And then you're gonna take a common factor of x and you're gonna be left with 2x minus 1, which is 0, okay? And the reason we are doing this is because we want to get two solutions, okay? Because the degree of x, okay, tells us that we need so much solutions. If it was a 3 there, which you're doing grade 12 cubic functions, you know you got to get 3 solutions, okay? So you need to watch out for this thing of having x squared equals to x, okay? Then you divide by x both sides, then you say therefore x equals to 1. You have one solution, you have not found all solutions. So to find all solutions, you must actually set up your equation in standard form. So I hope you really refrain from that, because you might lose some marks by not seeing that you've got other solutions. So from this, then you know that x equals to 0 or x is equal to 1 over 2. Okay, then you know that that's what you get. Now, how about this equation? What happens if I give you this equation, guys? What if I say 2 cos square x is cos x? What about this equation? Looks scary, huh? But be not dismayed. It's the same thing. Suppose you take cos x, okay, to be k, then you actually have 2k squared is equal to k. And you can again write this in your standard form, and you see that actually you're gonna have 2k minus 1 there equals to 0. So therefore, at the end of the day, when you know that, oh, actually this thing factorizes so easily into 2 cos x minus 1 equals to 0. Okay, and from here, you can really get the general solution, because you know, let me write it here, you know then from there that cos x is 0, or 2 cos x minus 1 is 0. And then here, if you get your, here you're gonna have you're gonna have to work in 2 ways. So here your ref angle is, I think that's gonna be a 90, because cos 90 is 0, okay? So that's going to be your ref angle. Remember, we spoke about boundary angles, guys. There's a video on that, okay? Then here, you're going to have 2 cos x equals to 1, and then you divide by 2 cos x is 1 over 2. Then your ref angle here, you know that x is 60 degrees, special angles again. Okay, so then you just solve, you know, the routine. You go for the usual routine. So this one actually is one of those that really make you to work a lot. And if you're not concentrating, you can easily lose some marks. Okay, so I'm not gonna get into the whole solution, because for now, you know, now you're gonna either have x equals to 90 plus k dot 360 degrees. And it's important to mention that k is an integer, and then or, okay, or x is where is cos positive in the fourth quadrant. So you're gonna say 360 minus your reference angle, which is 90, plus again here k multiplied by 360. Important to mention that k is an integer. And then you know 360 minus 90 is 270 plus k times 360, and k is an integer. Okay, so that's it. Then you come this side, you're gonna do some work again. 60, okay, so for your first solution is 60 plus what? K dot 360, and important to mention that k is an integer. Or you're gonna take the way is cos positive again, because the ratio there is positive again in the fourth quadrant. So we're gonna go there, and then again k is an integer. You'd excuse my writing, and this is 300 plus k dot 360. K is an integer. And that's really it, guys. That's how simple it is. That's how straightforward it is. You don't need to stress when you've got this stuff. That's just how straightforward they are. So yeah, that's about it. We ended there, and I hope you are following. Maybe I should leave you with a problem to try. Okay, so as usual, so try and solve this one. Again, you may need, or actually not you may need, you are bound to factorize. So how about this? Okay, plus 2 cos x. Oh, I did a cos one. No. I'm not going to give you a cosine one. Let me give you a sine one. So I'll give you the sine over here. Yeah, so that you do some more thinking on your own. So how about 3 sine? I keep on going back to cos. Okay, my bad. Okay, so try this exercise. 3 sine squared x. Okay, and then this is plus 2 sine x. Okay, is equal to 1. So try this one. You just finding the general solution. Okay, and that's about it. As you can see, we used identities here. I'll just take a last one in the next video where we use again identities in a non-obvious way, and then we talk about restricting the general the identities, or finding values where the identity will not be true. Until then, I'll catch you later.